Thank you. Thank you very much to be with us. Today we're going to talk about Scaleway first, and Luca will introduce us more about serverless, and then we will have a demo to see how to monitor glacier melting with serverless and how to build up application APIs with serverless. And at the end, there will be a Q&A questions for you. And here is the speakers of today. I am the product marketing manager of Scaleway, Chloe, and we are very happy to have our product manager, Luca, and also our develop engineer, Thomas. And we are super happy to have one of our happy customer, Aurélien, to be with us to share with us more about his serverless experience with Scaleway. So let's get started. For those who do not know Scaleway before, we are the cloud of choice, and we are leading European cloud provider with more than 20 years of infrastructure experience. And at the moment, we have 6 data centers, with 4 located in France, 1 in Netherlands, and 1 in Poland. Since 20 years, we have been supporting the cloud journey of more than 25,000 businesses in over 160 countries, especially those fast-growing startups. And we are also backed by our parent company, Iliad Group. So our public cloud ecosystem is innovative and designed for developers. And what makes it different from other cloud provider is that, first of all, we're going to ensure your data sovereignty thanks to our multi-cloud tools and infrastructure. And we have also a flexible and cost-effective price model comparing to our competitors. And we offer you the best developer experience. We are very proud to say that we are very close to our customer. Whenever you need, you can reach our product team directly on our Slack community and exchange with all our all our clients and all our developers there. And we also have a very complete cloud ecosystem where whatever you need for your cloud infrastructure, we have it for you. For example, we have product lines from Elastic Metal, compute product to network, storage, containers, serverless, and all the way to managed services. And so we have anything you need, and we are here for you whenever you need. And now we will have our product manager, Luca, to tell you more about serverless.
Hi everyone, thank you, Chloe. So at Scaleway, as Chloe said, we aim at offering uh, everything our clients need to manage their infrastructure, whether they want more control, own their server, and just put it in our data center, having dedicated servers um, as a service using our Scaleway Box offer, or through our public cloud ecosystem, Scaleway Elements. And even it's in our Elements portfolio, we have different types of option if you want more control or less administration. Of course, if you want more control, you can have our dedicated offers such as bare metal or elastic metal or instances, which are more of you can pop up easier. And if you don't want to manage something, we also have managed services such as managed databases, managed Kubernetes. And if you don't want to administrate your infrastructure and just use computing resource, storage resource as a service, we have our serverless offers, which is composed of several products. But serverless is not just one product. It's a dream that the cloud feels like one big computer, where user they don't know anything about server, they just write code and push it to the cloud, and it works just as it works and scales just as if it was on a single computer. On the other side, the providers doesn't um, requires him to pay beforehand and bill him actually for what they actually use. It's not just a single product, not a range of product, but an image of the cloud and something that we want to bring. As I said, actually, it's not just a product, but rather a product portfolio to create application without managing servers using serverless compute resources such as functions, containers, messaging, or to store data without having to manage everything. And with scaling already handled, we, for example, object storage, or our upcoming serverless database. The common characteristic of this portfolio are automatic scaling, so you don't have to care about scaling up or down depending on your demand. So it's way more elastic than, for example, simple instances with Docker. It can scale down to zero, which um, combined with a pay-per-use business model, enable you to have a really cost-efficient infrastructure, um, application infrastructure, because you don't have to manage anything behind. No disk, no CPU, no server. Everything just work. Um, our positioning at Scaleway through this full range of products is to be an European alternative to a market that is as of today, dominated by strong US-based or China-based players such as AWS, Alibaba, or GCP, but also to strengthen our cloud ecosystem by enabling more use case in combination we will see with other products at scale, such as Kubernetes instances or databases, but also to provide easy and simple way to build microservices-based application to our user. So on the top, for as of today, we're going to talk about serverless functions, which is a bit like AWS Lambda and enable to run code in the cloud is easily without worrying about infrastructure. It's scaled down to zero. You only upload your code using the console or frameworks, just Terraform or serverless framework, deploy it, and it runs when it is required. Um, a bit of infrastructure on serverless functions. So it's based on our other projects such as instances, capsule Kubernetes cluster, on top of which we have several things, but core the core components of the serverless software is native that enable the serverless pattern. So users generally push their code through our API. With this code, we build an image that we store in the container registry, and when there's an incoming request or an event such as cron jobs, um, Knative will pull the image and deploy it on nodes and scale it based on the incoming demand. And we offer a bunch of tools to monitor the application, something, and especially an upcoming integration with our observability product that will enable you to manage your log and metrics in in a, sin- in a single place. But if you don't, or if you can't use what we provide using function, for example, if you don't want to use Python, Node.js, or Golang, if you want to use Java or C++, or if using, for example, Python, you want to do data science or machine learning and you require some specific libraries, you can do it simply on function. So to fill the gap, we develop serverless containers, which is based on the same technology, which has the same benefits, scaling down to zero, automatic scaling, and other advantages. And instead of having to push your code, you push container, which is um, easier for some people to manage and to scale. But what is a good serverless use case? Because when coming to this new kind of products and new way of conceiving application, you can think about how can I use it. So a good serverless use case, in theory, is something that is synchronous and easy to parallelize, so that you can benefit from the scaling capabilities of serverless functions or containers, but without the risk of encountering, which is called cold starts when scaling down and from zero. It can also have infrequent demand. One good use case is of serverless is to absorb traffic spike. One good example is Lego, who use a serverless architecture to automatically scale for Black Friday and Christmas while remaining cost efficient for the rest of the years. And also stateless, because since you for now scale to zero, the data that you push to your functions is not stored anywhere in the function. It's not kept in memory, so you have to think about it when writing your application. So um, the idea of serverless at the moment at Scaleway is to supercharge what you already can do with what you already have, such as instance or Kubernetes. You can offload parts of your applications to serverless for example, file transformation or database actions that are infrequent or where you can't predict a load on that. You can perform time-based activity, for example, regularly push data to database or or push data from file to send an email. And you can also push part of your test environment. If it's containerized environment, you can push it on serverless container and then deploy it everywhere you want, because the architecture of serverless containers make it really open. But you can also use in another way, which is to manage your infrastructure. You can integrate your serverless functions, for example, into your infrastructure as code, deploy everything for Terraform, and have your instances automatically shut up and down in the weekend or during different time of the year. You can schedule um, maintenance backup of your maintenance or backup from your databases, instances, or everything else Scaleway. Uh, it's just a wonderful tool to do that. And now I'm going to give the mic to Thomas, who's going to show you some potential use case of serverless, but true serverless use case with nothing else than serverless functions, containers, and databases.
So good morning, everyone. Welcome to this presentation. I'm really happy to be here to talk about the serverless ecosystem. My name is Thomas Take, and I'm a DevOps engineer at Scaleway. I'm working on serverless functions and containers, and also many other subjects like maintaining some open source serverless related tools, improving user experience, improving performance, working with the community, and so much more. Today, I want to talk to you about my passion for hiking and exploring mountains and doing some crazy sports. Mountains are very impacted by the climate change. There are a lot of obvious and visual changes that are visible, for example, melting glacier. To be able to observe and analyze glaciers melting, we can imagine some ways to gather important data about this phenomenon. Data is not a solution, but it can help to understand our environment and to make everyone aware of what's happening. Also, we can aggregate data to find interesting correlation. For example, I can connect my tools to open APIs, for example, weather APIs, pollutions, CO2 rates. So let's build a simple tool that can help to create a shared bank of data that can be used for analysis by different kind of tools. For example, we can cross the amount of snow on a glacier versus the temperature. And I'd like to be able to share my findings with other scientists and, for example, with teachers and schools. A lot of data is available on the internet, and the first thing I want is visual data of glacier. There are a lot of open webcams pointing to mountains that are often used for weather forecasting and for checking skiing conditions. So let's use them to create our bank of images. What I want to do here is to record periodically and to connect to different webcams to read their data, their images, and to store everything somewhere and to expose my results. So to do this, I have some technical requirements. So I want to create something that easily scales up and down, and I don't know anything about my audience, so I want something that can manage a lot of inputs, for example, a lot of webcams, and something that can manage a lot of requests with a decent response time. Then also I want to focus on the code. I want to save time for hiking. In this kind of project, having a very low energy impact is important to me. and also it will be cost efficient. So let's see how we can reach all of these requirements. So the first, so I wrote a tool using a Go language that connects to one or many webcams, and it saves the captured image to a hard drive and adds an entry to a database and storage. For now, I choose to rent an instance, for example, an instance at Scaleway. So I have to select my CPU, my memory, my storage, to choose my operating system, to configure everything on my machine. I don't want to update my software using SSH, so I want to set up continuous integration and continuous delivery for my application. As I said earlier, I want something that scales easily, and I don't want to lose my data, so I need to manage my backup. At the first look, it seems simple to use an instance for this kind of project, but there is a lot of concerns that we need to care about. For example, security, network updates, auto-scaling, deployment, and monitoring my application and my instance performance. And to manually do backups, to manage hardware upgrades, and to still be productive when deploying application. So let's think another way to do this in the serverless way. So yeah, I chose to use a function that is automatically called once a day using serverless functions at Scaleway that will gather all the data from the webcams, and I will store it in a serverless database and an S3 storage. Then I used a serverless container at Scaleway to expose my website to show data to everyone. So to deploy this easily, I have several choices. I can use the Scaleway console directly in my web browser. I can use the Scaleway API. I can use Terraform. For my use case, I chose the serverless framework. So it's an easy framework to deploy a serverless project with just one command and a very low configuration. It can store my credentials to connect to my database, and I can add my own domain using it. As you can see on the right, I have my two projects, my container and my function, in the same folder. And with just one command, I can deploy everything and monitor and manage everything. The updates are very easy with serverless framework. So let's see how it looks in my environment. So I will share my screen. So just here is my project. This is my input file for serverless framework. I just described two services, my function and my container. In my function, I have just one configuration file with the runtime I want to use. I choose Go, but at Scaleway we have Node.js and Python that are available. And here is my credential, and I choose to call my function every day at 14, automatically. And for my container is also very easy. I just give the path to my images with my min scale and max scale for my container, and my listening port. Here is my custom domain for the demonstration, and my code is very simple. It's just a web server that listens to some routes to serve the data to to everyone. To deploy, I just to type serverless deploy command, and then it will deploy my function and my container in the Scaleway ecosystem. In the console, I can see here is my function, and here is my container. I have all the metrics and logging I need, so I can monitor everything. I can monitor the upscaling and downscaling for my container on my function. So it's really easy compared to an instance. So, sorry. So for going further with this project, we can imagine coupling serverless function with, for example, a GPU instance to do some hard intensive image analysis tasks. So, for example, we can imagine to start a GPU instance once a week to scan all of my images, to, for example, compute the percentage of snow in each image, to compute the percentage of snow melting between all my images, and to gather, for example, some weather data, for example, computing the percentage of clouds I see in my images. You can I can show you I forgot to show you the result. So if I go to my demonstration, we can improve the front end, I know, but here is a list of images that have been gathered by my function, and I can download them and find everything in one page. And I just have my serverless framework config file, my database, and my S3 at Scaleway, and I don't have to manage everything on an instance. I don't have to manage a SSH connection or network, and it's really easy to me and for my use case. So we can imagine a lot of improvements for this project, and for the moment it runs since 2 weeks, and I don't have any problems, and I'm really happy to use it. So thank you for listening to my on my use case, and I let Aurélien talk about his case.
Hello, I'm Aurélien Schwab from Atixis. I will do the presentation in French. I can do it in English if there is a real need of English. No? Okay. Don't hesitate to say if you want to have some information in English. Donc je suis Aurélien Schwab, je suis directeur technique chez Atixis. Donc on fait du web, on fait des prestations web, aussi dans le domaine du cloud et un peu dans plein d'autres domaines de l'IT. On a notamment réalisé l'application Golf Performance. Donc c'est notre cas d'usage aujourd'hui. Donc dans l'application Golf Performance, on a quelques petits besoins, notamment par exemple la météo, donc des prévisions en temps réel. Un système de messages pour que l'application puisse communiquer avec les autres applications pour, par exemple, s'inviter à des parcours, s'envoyer des scores sur des exercices d'entraînement, des choses comme ça. On a aussi forcément tout ce qui est gestion de compte, recherche de contacts, plein d'autres petites fonctionnalités qu'on retrouve souvent dans une application. Et du coup, on a décidé d'utiliser serverless pour des raisons évidentes qui ont déjà été énoncées. Nous, ça nous permet de nous passer totalement de l'administration système. Pareil pour l'infrastructure, aucune infrastructure à gérer. Donc, ça veut dire, en théorie, au-delà de ce qu'il faut modifier dans le code pour plein de raisons, que ce soit pour la sécurité ou pour l'évolution, absolument aucune maintenance. C'est extrêmement scalable. Donc, quand on a vraiment personne, par exemple, au début qui utilise l'application, on n'a vraiment aucune instance d'instances de fonction qui sont lancées. Donc, comme c'est du pay-per-use, du coup, on n'a pas de frais inutiles. Et si jamais il y a de la demande, automatiquement, les instances de fonction sont lancées et on a fait des tests, tenir une charge vraiment énorme sans avoir besoin de dépasser ce qu'on peut déjà faire avec les quotas actuels de Scaleway. Donc on s'est vraiment concentré totalement sur le code. Du coup, ça nous a économisé énormément de travail. Comment on utilise Serverless chez nous? Alors, on a utilisé Node.js, la version 14 à l'époque. On déploie tout ça avec le framework Serverless, donc en ligne de commande avec des fichiers de configuration. On a créé un fichier command.js qui nous permet de regrouper tout le code commun à plusieurs fonctions dans un seul fichier. Dans nos fichiers de configuration, on a des variables d'environnement et des secrets. Donc, il y a deux façons de le faire. On peut le faire dans la console. Comme nous, on utilise Serverless, vu que c'est écrasé à chaque déploiement, on le met dans les variables et les secrets de Serverless dans le fichier de configuration. Peut-être que plus tard, il y aura une évolution où on pourra mettre tous les variables et les secrets directement dans la console, que ce soit géré par une équipe et le déploiement soit géré par une autre équipe. On a utilisé pas mal de librairies, notamment PG pour la base de données, parce qu'on est connecté, je vous montrerai plus tard après sur le schéma, à une base de données. Crypto pour tout ce qui est chiffrement hash, CryptoKit, parce que comme on travaille notamment application sur iOS, avec des technologies d'iOS, on est obligé d'utiliser une librairie un peu spécifique, comme le chiffrement est un peu spécifique chez iOS, notamment pour le chiffrement asymétrique. On a d'autres librairies pour des API externes. Par exemple, si on doit contacter des API externes en HTTPS, voire en HTTP2, c'est le cas pour les API de Apple, par exemple. Et du coup, avec ça aussi, JSON Web Token, en plus de HTTP2 pour certaines API. Pour ce qui est de la connexion à Object Storage, on utilise le SDK d'AWS. Et pour tout ce qui est, on va dire, connexion aux API, on a configuré des endpoints personnalisés. Donc, à chaque fois qu'on redéploie, bon, ça n'arrive pas souvent, mais imaginons qu'on change de namespace, des choses comme ça, on change directement dans nos enregistrements DNS le lien de la fonction. Et chez nous, dans notre application, les endpoints ne changent pas, ils sont personnalisés en fonction de notre domaine. Pour l'instant, on a un CDN externe pour gérer tout ce qui est connexion aux API, mais on verra plus tard, on va peut-être basculer sur le CDN Scaleway. Pour des besoins de test, parce que ça met un petit peu de temps à être déployé, les fonctions, on a développé en interne. On a développé en interne un outil en Node.js pour émuler un petit peu le fonctionnement de Serverless pour pouvoir faire des tests directement en local. Ensuite, donc, c'est pas très important d'essayer de comprendre le schéma. Ce qu'il faut voir, c'est qu'on a pas mal de fonctions que j'ai mis ici en italique avec le logo de fonction, certaines sont connectées à Object Storage, d'autres à la base de données, et qui interagissent aussi avec des API externes. Donc, je vais parler de toutes ces fonctions qui sont donc derrière le CDN, qui nous permet de rajouter du cache, parfois de la compression, protection des DOS, ce genre de choses. Alors, je vais parler déjà d'API plutôt basiques. Donc, on a une fonction qui sert en fait à faire des recherches, tout simplement. Là, c'est dans des utilisateurs. Donc, il faut imaginer un champ de recherche d'utilisateurs pour s'ajouter comme sur un réseau social. Donc, on a fait une fonction qui permet de rechercher par numéro et par texte. Donc, c'est une fonction qui est connectée à la base de données. Et juste en tapant un texte en paramètre, elle va aller chercher dans la base de données et renvoyer des résultats si on en trouve. Donc, un cas plutôt simple. Ensuite, on a une fonction un peu plus complexe, on va dire, parce que c'est une fonction qu'on utilise, nous, qui nous permet de stocker des fichiers dans l'Object Storage. Donc, on envoie les données dans la requête. Nous, notre fonction, elle fait plein de choses. Elle va hacher le fichier parce qu'on les stocke étant donné que c'est par hash dans l'Object Storage. On va rajouter des tags pour savoir quel type de fichier c'est pour gérer leur cycle de vie, par exemple. Et on va aussi rajouter des headers de cache pour le CDN et tout ce qu'il y a derrière, pour avoir une mise en cache assez longue, ce qui nous permet d'économiser des requêtes à l'Object Storage. On a aussi une API qui sert en fait à envoyer des notifications à nos utilisateurs. Donc c'est une API de notification push. Donc elle est connectée par exemple à une API externe chez Apple. Donc, quand on a besoin ou quand les utilisateurs ont besoin de s'envoyer des notifications entre eux, par exemple, quand là, dans notre exemple, ils s'invitent à quelque chose, ils ont des notifications push dans leur portable, ça passe par cette API qui va ensuite contacter l'API d'Apple. Donc, il y a des vérifications qui sont faites, le contenu de la notification, l'utilisateur, est-ce qu'il peut l'envoyer, donc tout ça est fait dans la fonction. On a une API un peu plus complexe, on va dire, parce qu'elle gère beaucoup de choses. Cette fonction, elle permet par exemple d'authentifier une application ou un utilisateur. Donc quand on crée un compte, on a une clé privée dans notre application qui nous permet de vérifier que c'est bien quelque chose qui est plus ou moins notre application, parce que oui, bien sûr, il y a des gens qui vont réussir à extraire la clé privée, mais qui nous permet de vérifier que c'est plus ou moins notre application qui essaye de créer un compte. Et pour ce qui est toutes les interactions des utilisateurs, on a des clés privées pour chaque utilisateur qui nous permet de vérifier que c'est bien l'utilisateur qui détient ce compte. Donc toutes les actions de modification, de création de compte, donc je viens d'en parler, donc connecter à la base de données. On a aussi des appels à des API externes d'Apple, par exemple. Le cas là, il est intéressant. Par exemple, quand on a un abonné qui prend un abonnement premium, il faut qu'on vérifie que cet abonnement premium est réel et que c'est pas quelqu'un qui essaye de pirater le système pour se faire passer pour un abonnement premium alors qu'il n'en a pas. Du coup, on récupère la transaction de l'abonnement et on a un appel à une API de chez Apple qui permet de vérifier que la transaction est bien réelle, que l'abonnement est toujours valide, tout ce genre de choses. Ensuite, on a aussi un système dans cette API qui nous permet d'envoyer des mails. Alors actuellement, on passe par une API externe, mais bon, plus tard, ça sera peut-être migré chez Scaleway. Donc par exemple, pour la récupération de compte, quand il faut changer, par exemple, la clé privée de l'utilisateur ou récupérer son backup parce qu'il a perdu son portable, son compte Apple, ce genre de choses, normalement, il a son email qui n'est pas stocké en clair, hein, mais il a son email, donc on vérifie quand il nous envoie son email, est-ce que son email est bien le sien. Ensuite, on lui envoie un mail avec un code de récupération, et ensuite, ça nous permet de changer sa clé privée, de le récupérer l'accès à son compte. Un truc dont je ne vais pas parler dans le détail quand même, c'est aussi ce endpoint qui gère la création de tokens pour les autres API. Donc ici, il y a une vérification nous qu'on fait par chiffrement asymétrique. Dans les autres API, c'est plus un token chiffré symétriquement, ce qui nous permet d'éviter plein d'accès à la base de données pour vérifier que la signature est vérifiée, ce genre de choses. Après, ça c'est technique, chacun met en place la méthode qu'il veut. Sinon, on a un exemple qui est très intéressant, que j'ai un peu plus détaillé que les autres exemples. Donc, c'est la météo. On a une API externe qui nous fournit des informations de météo, mais on ne peut pas non plus y accéder directement depuis l'application, parce que, par exemple, ça fait énormément de requêtes pour parfois le même endroit, donc c'est inutile, on a des quotas quand même. Donc, ça nous permet de mettre en cache certaines requêtes à la météo. Donc, si tout le monde demande la météo au même endroit, on va avoir une requête qui va se faire à la fonction et le CDN va mettre en cache pendant que la météo est valide grâce au header le temps que la météo ne soit plus valide. Je ne sais plus combien on a mis, 10 minutes par exemple. Je crois que c'était 10 minutes. Donc, ça nous permet déjà de vérifier les fonctions que la requête est valide, parce que si on avait directement des accès aux API externes sans vérification, n'importe qui pourrait faire n'importe quelle requête avec nos tokens. Donc, entre autres, ça permet de cacher aussi notre token privé. On a des headers de cache qui nous permettent d'avoir moins d'accès aux API, voire même aux fonctions. Et dans certaines fonctions, on rajoute de la compression pour que ce soit, plutôt que ce soit fait sur le CDN, c'est fait directement dans la fonction. Maintenant, on a une API qui est pas forcément outdated, mais qui est juste pourra peut-être être remplacée par la suite. C'est celle qui gère les messages. Donc, on a un système qui permet d'envoyer des messages aux autres utilisateurs, que ce soit un utilisateur, plusieurs utilisateurs, voire un système qu'on utilise plus nous, mais pas vraiment intégré dans l'application, c'est de pouvoir envoyer des messages à tous les utilisateurs. Et du coup, dans cette fonction, on a aussi un autre système qui permet de récupérer ces messages. Donc, c'est plus ou moins une boîte aux lettres. Donc les migrations, donc potentiellement la fonction de message pourra être remplacée par ce qui arrive bientôt chez Scaleway, Scaleway MNQ. Pour le CDN, potentiellement pareil, Scaleway, le CDN de Scaleway. Et pour ce qui est de la base de données, plus tard, il y a un service qui est prévu pour Serverless spécifiquement. Actuellement, on se connecte au Managed Database de Scaleway, mais plus tard, c'est prévu d'intégrer directement peut-être Serverless DB. Et pour ce qui est de l'envoi de mail, il y a le service Scaleway Theme. Donc voilà, si vous avez des questions, je reste à votre disposition et si vous avez des besoins, vous pouvez nous contacter.
Thank you, Aurélien and Thomas, for these great demos. So now for the Q&A, we have third question. Hello, we play with Scaleway functions, but got limited by the support of triggers. While your doc talks about bucket event triggers, it's not yet supported as far as I know. When do you plan to support more triggers than just cron? So there's an ongoing project, as already mentioned, which is called messaging, which is basically a messaging as a service products, which will be compatible with AWS SNS and AWS SQS. The private beta is on, and you can already test it. And the serverless dev team has started working on the integration with this product, which means that by the end of the year, you'll be able to trigger functions or containers using messages and events that will be published into an SQS queue. And we are at the moment looking for supporting more event source. As far as bucket notification is concerned, um, it will come next year. We are working closely with the object storage team to enable this feature, but there's lots of things to do with the S3 protocol and object storage to make that possible. So we first start with messaging queues and then extends to other kind of events. Julien, you talk about scaling function, but you connect your function with a Postgres server. Do we have limit on open connection? Did you propose alternative solution to allow storing relational data with 1,000 open connections? Not sure. I'm the one. Oren is replying by text. So what can I say about it is we're working again with the Postgres and managed database team to enhance the connections between serverless functions and containers and database resource. We're working on enhanced security and figuring out how to open more connections. And on the other side, we are working on a totally new product, which is still in discovery phase and will enter soon development phases, which is called serverless database, which will be better integrated with our serverless offering and will also enable more elasticity with databases. Hope this answers the question. And Aurélien is writing down a reply. Aurélien again, regarding hosting an IP via function, what is the best strategy in terms of granularity? One function for each API endpoint plus HTTP verb, grouping all verbs in a unique function for a given endpoint, grouping several REST paths into the same root endpoint functions, any guideline? I don't know if Aurélien can answer this question.
I can answer.
Or Thomas,
So,
go ahead.
about this question, it depends. If you want to do some load balancing, it can be very useful to have one function per verb. For example, if you got a lot of post and just some one or two get by second, it's better to separate your different functions by verb to be able to use the serverless at its best in terms of scaling up and down. Yes, it's often better to have one function per verb in heavy application, but if the statistics of usage are more low, you can do everything in one function. It depends really of what you want to do and your scaling concerns.
The other thing you can do is to put something that we don't have yet as managed product, but an API gateway such as Kong, and in the same way that Thomas used um, serverless framework and serverless compose to deploy serverless functions and container, you can have everything in the same project. One of our solution architect has made a project about it. I think it's on GitHub. I can publish it in the Scaleway community channel so that you can have a look. And Oriam and answer, we have one function per endpoint and use HTTP method, but I agree with Thomas for some use cases. Okay. Julien, do you have improvements in progress to have better wake up function? I think you mean cold start. We have several projects ongoing about that. I can't tell more at the moment, but we are thinking of different ways to have a better response time for functions. And one of our internal objective is to lower it to something around a second, and that's one of our objective for the next year. Christian, talking about connection limits, are there any plans to cater more towards real-time HTTP connections like WebSockets, even source? I think I don't understand the question. Thomas, do you understand the question?
Not really, sorry, but I think it's about the request per second, maybe, or I don't know if it's about scaling. We already have a lot of options. Then you can explore in the console or API. So let us know if you need some more resources, and do not hesitate to send some message to us.
Okay. Next question. I'm interested in using serverless with Prefect, which requires an agent to be pulling the service to start work in the pipeline. It seemed like this agent could use a very small, long-running serverless container, very cost-effective, around €2 per month for the smallest container. You can use a small container to do that if you want, but be careful. The requirement for using serverless um, containers is that this container had the web server inside, just to listen for the port to be scaled on. Because if you don't have a web server, the system don't know how to wake up the container. And depending on your use case, um, it can be effective, but you can also just use the a small instance with Docker, for example, um, to support your application. That really depends on if your application require a web server or if you're ready to have a web server. And also be careful because the lowest tier in on serverless is a bit slow, but the next memory slash CPU tier is for almost for a bit more than €4 per month. So I think it would be better to use that resource range. Mm, Very excited about your upcoming serverless offering. I see how this will complete most of our future requirement. Is there any chance to get a hand on serverless queues, transactional emails? Yes, if you want to try them, you just, and I think I put it in the chat, we have the scaleway.com/betas when you can find, um, um, when you could subscribe to news and to get involved in our upcoming betas, serverless queues, transactional emails, observability, and even have some news on CDN and VPN offering. I might have missed something in the talk, but can serverless containers use a GPU? No, not at the moment. That's something we have in mind, but for I think the long time, not not next year. I think the reason is that if you can uh, separate a CPU or a virtual CPU into several slices of that vCPU, you can't do that for a GPU. For now, with the existing technology, that is going to change. But with the existing technology, if you buy a GPU, if you have a GPU, you can slice it. You can only use the whole GPU securely. So when we will be able to slice a GPU into virtual GPU, uh, we will probably add it to the serverless containers offering, but at the moment we can't.
I think there is a question for Thomas from Cedric in the chat, maybe.
Yes, so it's a technical question. I answer to Cedric. So for technical questions or support questions, do not hesitate to join our community Slack. We have a serverless function and serverless containers channels to send this kind of questions. Thank you.
Okay, one last question from Christian.
I see you offering a number of different runtimes. That's great. Any chance to get more runtime for language not currently supported? Think PHP. Yes, that's totally something we have in mind for the end of the year, I think. We have PHP in mind. If you want to talk with us about it, what's your use case, anyhow, you can contact us on Slack. And we are also thinking about maybe a Rust runtime, depending on if because some people already ask it on the Scaleway request website. If you need anything, functionalities, new features, you can either ask on the Slack channel. We'll happily answer all your questions and needs. Or if you want more visibility, you can put it in this specific Scaleway requirements website that we also consult almost every week.